Welcome to A-Level and AP Physics. In today's class, we will discuss important past paper questions on radioactivity and electric field from October-November 2020 paper 2. These questions are very important because you will see same type of questions in many years past papers. Our first question is from October-November 2020 paper 2. 1. And for part A, we need to state a similarity and a difference between a down quark and a down anti-quark. If you simply remember the charge on down quark, the charge on down quark is equal to minus 1/3 of the charge on single electron. So simply you can write down. Now the next thing you also need to understand, what is the charge on down antiquark. So down antiquark means this is antimatter, so the charge on this one has to be opposite, that equal in magnitude. So the charge on down antiquark will be 1/3 of the charge on single electron, that this is positive. Based on this one we can write down our answer. So simply for similarity you can say equal magnitude of charge. So simply we can write down what is similar between these two. Equal magnitude of charge, we can simply write down like this. So they have equal magnitude of charge and opposite sign of charge, we can write down, but opposite charge, so you can say opposite charge, or sign of charge you can say, or simply if you say opposite charge. So if you write these 2 points, you will get 2 marks for this question. Let's try to understand a little bit more about down quark and down anti-quark. First of all, we need to understand down quark is a particle, or we can say it's a matter. So this is matter, or you can say particle, and down anti-quark, this is antimatter. So this is also the difference. You can also say one is matter and other one is antimatter, and both of them, they are fundamental particle. Means the down quark, this is fundamental particle, means it cannot be broken into smaller particles. So we can say this is fundamental particle. So the down quark is fundamental particle. Any type of quark is a fundamental particle. Means down anti-quark, this is also fundamental particle. Means this one cannot be divided into smaller particles. So this is also fundamental particle. So this is the similarity between these two, and this is the difference. The second thing we need to understand, matter and antimatter, or particle and antiparticle, they have always same mass. So it means down quark and down anti-quark, they also have the same mass. So they have the same mass. So this is the similarity. You can write down similarity here. So this is also similarity between these two, and this one you can use as a difference between them. You can say one is matter and the other one is antimatter. Next question is simply asking us about the number of protons and number of neutrons. If we look at this nucleus of aluminium, if we look at this nucleus, so at the bottom we have Z, means this is atomic number. In fact, this is equal to number of protons. So simply we can write down this is equal to number of protons. And 25, you can see here, 25 is the mass number. So A is mass number. We can simply write down here A is the mass number. Now number of protons, quite straightforward one. So simply number of protons is equal to 13 is equal to atomic number. We can write down here. Now the question is that how to find number of neutrons. Let's say n is the number of neutrons. So number of neutrons simply is equal to mass number minus atomic number, or you can say minus number of protons. So in this case mass number is 25 and atomic number is 13. So the number of neutrons are equal to 12. So simply for this one we can write down number of neutrons equal to 12. Second part is asking us to show that the charge is 2.1 times 10 to negative 18 coulombs, and this is for a nucleus. For a nucleus, we need to understand in the nucleus there are protons, and also in the nucleus there are neutrons. If you look at the charge of proton, means, let me write down here, charge on proton is equal to 1.60 times 10 to negative 19 coulombs. But if you look at the charge on neutron, neutron has no charge. So neutron 0 coulombs, mean it has no charge. We need to find the charge on the nucleus. So for that purpose, simply we need to understand the total charge Q. This will be equal to number of protons. In this case, we have 13 protons multiplied by the charge on single proton. So if we just multiply this, we will get our final answer, that is equal to 2.1 times 10 to negative 18 coulombs. So this is the answer. For part C, it is given to us that nucleus in part B is moved along a straight line from point A to point B. Means it is moved from point A to point B along this straight line in a uniform horizontal electric field in a vacuum. Vacuum simply means that we no need to consider air resistance. Now, if you look at the force acting on this nucleus at this point, and this nucleus is positively charged, so direction of force is in direction of electric field, so the electric force will be acting in this direction. Let's say when the nucleus is at this point, if we find direction of electric force on nucleus, again this will be equal to Fe, and its direction is to the left, because this is in a uniform electric field, so magnitude of force is the same. If we consider direction of electric force on this nucleus at this point, so again this is to the left and its magnitude is the same. So it simply means that force in this case is constant and it is always directed to the left. Now if we need to find out the work done by electric force, means work done by electric force, so that will be simply equal to electric force times the distance moved in direction of force. In this case, electric force, simply we can find out this will be equal to EQ times D. EQ times D. And D is a very important thing we need to understand. So which distance we have to consider, because the force is always acting along horizontal, so we need to take the horizontal distance, means we need to take this distance. So it means D in this case, this is equal to 4.0 centimeters, or we can say this is 0.04 meters. Value of E is already given, so we can write down this is E. 11 times 10 to 3 volts per meter, so this is value of E. And the value of Q we have already calculated in part B, so that was equal to 2.1 times 10 to negative 18 coulombs. And the distance is 0.04 meters. If we all multiply, our final answer will be 9.2 times 10 to negative 16 joules. But this work done is negative. Why this work done is negative? And the distance covered, this is to the right. So the angle between them, this is equal to 180 degrees. So simply we can say work done by electric force, this is negative. But the work done by applied force, will be equal in magnitude, but work done will be positive. So this is the work done. Why these two works are equal? Because in this case there is no change in kinetic energy. So the work done by electric force, this is negative, and work done by applied force, means I can simply say by F force, this is positive, and that is equal to change in kinetic energy. Because there is no change in kinetic energy, it means these two work are equal. So our final answer will be 9.2 times 10 to negative 16 joules. This question is from October-November 2020 paper 2-2 and very similar to paper 2-1 from October-November 2020 because this is also asking you a similarity and a difference between up quark and up anti-quark. We have discussed a lot about this one. We have discussed quark and up anti-quark. They are matter and antimatter. So simply again we can write down the difference between these two is one is matter, the other one is antimatter. And what is similar between these two? These are fundamental particles. We can simply write down their fundamental particle. Means quark is fundamental particle and anti-quark is also fundamental particle. So we can write down here anti-quark is also fundamental particle. The next thing what we can say is about the charge. The charge on up quark, this is equal to plus 2/3 of the charge on electron, but the charge on up anti-quark, because this is antimatter, so the charge has to be opposite. So this is minus 2/3 of the charge on electron. So if you have this understanding, we can write down our answer. This is how you can write down the answer. Simply you can say matter, antimatter. So this can be the difference. This can be the difference. We can say one is matter, the other one is antimatter. If we need to write down what is similar, simply you can write down both of them. They are fundamental particles. From here we can also say that magnitude of charge is the same. Up and up anti-quark, they have same magnitude of charge, so they have same magnitude of charge but opposite. But sign of charge is opposite. So but opposite charge. So these things, basic things, very common question. If you are clear about this now, in future you can answer. So this is how we can answer this question. I hope it is clear. Let's move on to next. For part B, it is given to us that electron is in an electric field and electric field is in vacuum. Question is asking us on figure 7.1, we need to draw arrow to show direction of the electric force acting on the stationary electron. Means electron is at rest at this point. We need to draw direction of electric force on this. Let's try to understand a little bit about electric field. Let's say our electric field is uniform. Electric field is like this. Let's say upper plate is positive and the bottom plate is negative. So direction of electric field is down. Now if we place positive charge inside this one, let's say we place positive charge here, direction of force will be in direction of electric field. But if we place negative charge like electron inside this electric field, direction of electric force on electron, it will be in direction opposite to the field. So if you look at this one, this is our electron and direction of electric field is to the left. So the force on electron will be to the right. So simply we need to draw this arrow. So this is how we can answer part 1. If we look at second part, it is given to us the electric field causes the electron to move from its initial position. Describe and explain the acceleration of the electron due to the field as the electron moves through the field. Now when the electron is moving this way, we need to understand how electric field is changing. So the first thing we need to understand is that electric field lines are getting closer. So we can write down electric field lines. Electric field lines are getting closer, so we can write down electric field lines are getting closer. So what this is telling us, getting closer means that E increases, means field is getting stronger, so the E is increasing. So we can say E is increasing. So if E is increasing, how about the force? Force F is equal to EQ. Q is the charge on electron If E increases, it means the force will increase. If the force on electron is increasing, so this is the force, we understand F is equal to ma. So A from here, simply we can say this is F over m. So if the force is increasing on electron, mass of electron is not changing, so it means that A will increase. So simply we need to explain that the force on electron is increasing because electric field is getting stronger, so the acceleration of electron will increase. Because this is not uniform electric field, this is non-uniform electric field. So let me explain to you how you can write down your answer. So simply you can say the first point, this question has 2 marks. We can say electric field. So we can say the first point we can write down. So this is how you can write down your answer. You can say electric field means E increases. So this is one point you can write. Electric field increases. The second point you can say the force increases, or you can say electric field increases, so force increases, therefore acceleration increases. Therefore the third, acceleration increases. Acceleration increases. So this is how you can answer this question. For this part, it is given to us that a stationary alpha particle is now placed in the same electric field at the same initial position that was occupied by the electron before. Question is asking us, we need to compare the initial electric force acting on the alpha particle with the initial electric force acting on the electron. Means that acted on the electron. In order to compare this one, first thing we need to understand what is given. It is given to us that same electric field. It simply tells us that E is the same. Electric field is the same. So this is the first thing. The second thing we need to understand is the charge on alpha particle and the charge on electron. The charge on alpha particle, the Q, this is equal to plus 2E. But if you look at the charge on electron simply is equal to minus E. So it means the charge on alpha particle, this is double than the charge on electron. That these two charges are in opposite direction. So let's try to write down the force. Now if you write down the force here, force is equal to F is equal to EQ. E is the same. So here we can write down this is plus 2E. So this is the force on alpha particle. If we write down the electric force acting on electron, that will be equal to E times minus small e. So it simply means that the force on alpha particle is 2 times as compared with the force on electron. But direction of force on alpha particle is in opposite direction as compared with force on electron. We can also draw here, for example, when our electron was here, the force on electron was to the right. Now if we place our alpha particle at this point, force will be to the left. So the force is in opposite direction. Let's say if this force is F, the force on alpha particle, this will be 2F. So that's all what we need to answer this question. If we have this understanding, then we can write down our answer like this. So there are 2 points we need to understand. You need to mention the force on alpha particle is twice the magnitude of force on electron. The second thing you need to mention is the force on alpha particle is in opposite direction to force on electron. For this question, it is given to us that there is a uniform electric field between plate X and plate Y. So these are 2 plates, plate X and plate Y. It is also given to us that plate X is at potential plus V and plate Y is grounded. So it simply means that here potential is equal to 0. It is also given to us that the distance between 2 plates, this is equal to D. Part A is asking us, we need to state expression in terms of sum or all of d, q and v for the magnitude of electric field. Electric field simply means the capital E. This is equal to the potential difference between 2 points, or we can say in this case between 2 plates, divided by the distance between 2 points, or in this case we are talking about plates, so the distance between 2 plates. In this case the potential difference simply is equal to V minus 0 divided by the distance between them is d, so it's simply equal to V divided by d. So this is how we can answer part 1. For the second part, question is asking us the magnitude of the electric force on the nucleus, means the magnitude of the force acting on this nucleus. Magnitude of force in this case will be constant because this nucleus is in uniform electric field. So the force we can write down, in this case force will be equal to F is equal to EQ, and Q is the charge on the nucleus. It is also given charge on nucleus is plus Q. E we have already, so we can replace E with V divided by D, and this is multiplied by the charge on nucleus. So this is our answer for second part. For this part, we need to calculate the kinetic energy of the nucleus when it reaches plate Y. When this nucleus was at this point, means at plate X, its kinetic energy is equal to 0 because it was stationary. So we can say initial kinetic energy of nucleus, this is equal to 0. When it reaches at this plate, means at plate Y, it has certain amount of kinetic energy. We can say that is kinetic energy final. If we need to calculate the change in kinetic energy, that change in kinetic energy will be equal to Ke final minus Ke initial. So simply we can write down. But Ke initial, this is equal to 0. It simply means that the change in kinetic energy, in this case, this is equal to kinetic energy final. Now we need to understand the change in kinetic energy. In this case, this is equal to work done by electric force. And work done by electric force, this is equal to force times d, the distance d. F, this is equal to EQ times t. So this is the force. But if we rearrange this one, we can simply write down this is ED times Q. But ED, this is equal to the potential difference times Q. In this case, the change in kinetic energy, this is equal to Q times delta V. We can simply write down, in this case, the kinetic energy at plate Y, this is equal to Q times delta V. You have to write down in terms of Q and delta V because question is asking you to write answer in terms of Q, V and D. So we can say this is Q times V. So in this case V is equal to potential difference. Let's try to answer part B now. For part B, it is given to us, state the change, if any, in the kinetic energy of the nucleus on reaching plate Y when the following separate changes are made. It means one change is made at a time. Now, first change is the distance is half, but the potential difference remains the same. Now, if you look at kinetic energy, we have found that kinetic energy is equal to Q times V. It is not depending on the distance between plates. So simply we can say that there will be no change in kinetic energy. So simply now if we go to next one, it is given to us the nucleus is replaced by a different nucleus that is isotope of the original nucleus. So this is very important. Isotope, it means the same charge on the nucleus, same charge because the same number of protons. So from here we need to understand the charge is the same with a fewer neutrons. Again we need to understand kinetic energy is equal to Q times delta V. For this part, only we change the nucleus. Distance is the same. Potential difference between plates is the same. The charge on the nucleus, that is also the same. So it simply means that again there is no change in kinetic energy when this nucleus will reach the plate Y, because Q is the same, delta V is the same, so there is no change in kinetic energy. For part C, it is given to us that nucleus of carbon-14 decays to form a new nucleus by releasing beta minus particle and only one other particle of negligible mass. This is telling us about neutrino. Now the next thing what we need to understand is that we need to find out, is it beta minus decay or is it beta plus decay? This is beta minus decay because in this case beta minus particle is emitted, so this is beta minus decay. So the first thing we can write down, this is beta minus decay. Now for beta minus decay, we need to write down this nuclear reaction. So in this case, we have carbon-14. This decays to another nucleus. Let's say the new nucleus is X by emitting beta negative particle. So this is negative particle. Now we need to understand this is electron, and electron is a particle, so we can write down here electron, and electron is a particle, so this has to be anti-neutrino, electron anti-neutrino, so atomic number mass number equal to 0. Now let's try to answer part 1. For part 1, we need to find out the nuclear number of new nucleus. If we write down here, this is 6, this is minus 1, so this has to be 7. This is 14, mass number 0, mass number 0, so this is still 14. Very simple one, so I'm just writing directly these answers. So it means the nuclear number is equal to mass numbers. This one has to be 14. And the proton number, this is the proton number. So this one is proton number. We often use letter Z for this, our atomic number. So this has to be 7. The next second part is asking us, state the name of the particle of negligible mass. So this is electron antineutrino. So this is E. So we can write down this is electron antineutrino. So this is electron antineutrino. Now you need to understand, if this is particle, this one has to be antiparticle, means it has to be antineutrino. This is the point you need to remember. So this has to be antiparticle.